Brunswick station on 2.
Go ahead on 2.
And this is a call for Huntsville on 2 regarding rodent research cameras.
And Huntsville's with you on 2. Christina, go ahead.
I have the Node 2 HD set up now into the GEM view if you would like to check it and come on board.
And stand by, we will get that routed.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready.
Canadian Space Agency, this is Mission Control Houston. Please call Station for a voice check.
This is Christian Riel at the Canada-wide Science Fair in New Brunswick. How do you hear me?
I hear you loud and clear. How do you hear me?
Bonjour, David.
Hello, David. We're so very happy to speak with you.
At the Canada-wide Science Fair in Fredericton, who are here to learn who are the Little Inventors winners. Are you ready to announce the first winner?
I sure am. So the first winner of the Little Inventors Inventions for Space is Connor Brown, who invented Space Boots imprints.
Hi, David. My name is Connor. I am 12 years old. I'm from St. Joseph's School in Acton, Ontario. I designed the space boot imprints. Most boots have the same zigzag pattern on the bottom of the sole. But with my idea, astronauts can see their designed boot imprint marks on the moon. With my invention, we can also tell which imprint belongs to who.
Congratulations, Connor. It's a very creative idea. And you know, Canada's joined a group of nations who are going to go back to the moon. So we'll need boots for that for sure. So maybe your invention will has a future. So keep thinking and keep inventing.
Thank you, David. Can you now announce the second winner?
Certainly. And the second winner is Amy Claerhout for her invention, the personal Canadarm.
Hi, David. My name is Amy. I'm 13 years old. I'm from Bow Meadow School in Bowman, Alberta. My invention is the personal Canadarm. It is a mini version of a Canadarm that can be attached to your bathroom wall. It has all the tools a human would use for personal hygiene. The tools are all built into the Canadarm to help astronauts get ready without having things floating out of reach.
That's a great invention. And you know, we could actually use this here because that's one of the problems we have is things fly away all the time from our care. So to have a one shop would be good. And you know, it was based on Canadarm. That makes me very proud. As you know, Canadarm is Canada's contribution to the space program up here on Space Station. And it does amazing things. Just last week, I had the privilege and honor to use it to capture a free-flying capture vehicle, a cargo vehicle. And you know, it wasn't even designed for that initially. That's just something that our smart engineers came up with after the fact. So it proves that when you keep thinking outside the box, you can keep improving the world around you. So keep doing that.
Bravo. Thank you, David. This unveiling was literally out of this world. Félicitations à nos deux gagnants.
To our two winners. Your inventions are now in space and are floating 400 kilometers above our heads. David, there are also many young people here who would like to ask you questions, so let's go right ahead.
In Ontario. You need a mic? There you go.
Hi, David. What would happen to a fizzy liquid, such as pop, floating in the space station? Would the bubbles move to the surface of the sphere, or would they just form and sit in the middle of the sphere? In other words, would the sphere turn into a ball of foam over time?
That's a very smart question. And you know, your description is just right. These bubbles, they have no reason to go one way or the other, so they just keep growing inside and they kind of merge. And what you end up is one giant, it makes the bubble of liquid get bigger and bigger and bigger as air inside, as the gas inside takes more and more volume. So that's what happens. It doesn't become a ball of foam, it becomes like a giant bubble with air growing inside it. It's pretty interesting. You know what, you give me an idea for an experiment up here.
Bonjour, Monsieur Saint-Jacques.
Hello, Mr. Saint-Jacques. I'm coming from Quebec. So starting on May 20th, 2019, the kilogram will be defined by the Planck constant. How do you weigh objects in space, and will this affect your work methods? So the object we weigh the most is ourselves, because for medical reasons we need to weigh ourselves, and we cannot use a weighing scale like we have in our bathrooms. We use inertia. I still have my mass here, so if I weigh myself, the weighing scale is the frequency of the weighing scale is going to change, like in the park. If you go on the swings, a young kid or an older kid, they have a different frequency. So it's not going to change our way of working, because we're not that precise in our medical weighing.
Hello, David. My name is Ava Fisher, and I have a question from Rachel, the little inventor of the fuzzy PJ dress-up spacesuit. When you face a problem, what is your best strategy to overcome it?
That's a very good question. So if it's a technical problem I have to solve, I just take a few steps back and try to find what I call the root cause of the problem. What is actually causing my problems? And often looking for the root cause will help you illuminate what the solution is. But sometimes problems are emotional, so that's of course a different kind of problem. When you feel angry about a problem, it's important to focus, I think, on the facts and try to keep your emotions under control so that you can think more clearly. But generally, that's how I proceed. I like to go back to the source of the problems and do what I call a stepping back, several steps back, and often that clarifies your vision.
Hi, David. My name is Corin. Hi, David. My name is Corin Acton from Ogama, Saskatchewan. Once when I went on a plane, I brought a bag of chips and the bag expanded on the plane. I assume this is because while the planes are pressurized, they are still lower pressure than normal. Is there a similar effect on the space station?
Yeah, you're absolutely right. Airplanes are pressurized at about the same pressure as you find on top of a mountain. So, maybe 80% of atmospheric pressure. That's why your bag of crisps, which is very airtight, looks like it's bloating up. It's just because the pressure outside is less than the pressure inside. But here on Space Station, we try to keep the pressure exactly like on the ground, exactly 1 atmosphere of pressure, just because it's more comfortable for humans. So we don't have those pressure effects. But if we get a hole in the station, maybe if a piece of space debris hits us and creates a little hole, then we can feel the pressure go down. And the first thing that we'll notice is our ears will pop, just like you notice on the airplane as it goes up. Your ears pop. That's because the pressure decreases in the cabin, and the air inside your body inflates a bit like the air inside the bag of chips.
Bonjour, Mr. Saint-Jacques.
Hello, Mr. Saint-Jacques. My name is Amy, and I come from Manitoba. My question is, what type of scientific research do you carry aboard the ISS? And do you have some results from these experiences that you could share with us? So there are hundreds of experiences ongoing and thousands since the beginning of the operations in many different subject matter, materials, new technologies, but lots of experience related to medical research. And it's very interesting for me because I'm a doctor, and this is because when you're in space, it's not good for your health. And the problems that it's creating can affect people on Earth, but it happens faster in space. So all the experiences on blood pressure and the reactions with weightlessness, this can help us understand cardiovascular diseases on Earth. Like another thing is bone density and the bones that get weaker. So we can help astronauts and then maybe develop medication and help older people when their bones are becoming weaker. So there are research as these that can help life on Earth and also help life for astronauts.
Hello, I am Francois Moret from Fort McMurray, Alberta. And my question is, considering that time, gravity, and speed are interrelated, does time change differently on the space station as opposed to Earth?
You know, if you look very, very precisely, yes. Here, space station, we're 400 kilometers above the ground. So the gravity here of Earth is still felt, but, you know, it's not fully felt in the 90%. So because we're slightly lower gravity, time goes by a little slower, but it's fractions of a fraction of a second over the length of my expedition. So, you know, it's not going to be the cure for me. But strictly speaking, yes, we feel that. As far as speed, you know, we're going fast on orbit, but the Earth is also going fast around the Sun, and the Sun is going fast around the center of the galaxy. So compared to our overall speed in the galaxy, the velocity of station is not adding all that much, although it is an impressive number, 8 kilometers per second. But you're right, all these relativistic effects predicted by Einstein, they're well demonstrable here on orbit.
Bonjour, Monsieur Saint-Jacques.
Hello, Mr. Saint-Jacques. This is coming from a school in Quebec. Do you get claustrophobic at times on board the ISS? Of course, we have a beautiful window, unfortunately, and we see the Earth, and this is the most beautiful landscape you can imagine. Like if you could go climbing a mountain, you have such emotions when you look at the landscape, and this is the same thing here, except that here the mountain is very high, 400 kilometers. I don't feel claustrophobic here, but I've never been either on Earth. I imagine that if someone was claustrophobic, it would be difficult for them to be away from the window. But here, for instance, this module where I am is 1/10 of the ISS. So it's not as small as you can imagine. It's quite comfortable.
Hello, my name is Neem Prasad. I'm from the East Kootenays, British Columbia. This is my question. My science project is on using insect protein as alternate protein source. I've read that NASA is considering using insect farms in space to feed astronauts, especially for prolonged missions. What do you think about this?
This is, you know, it's a big question, a big problem, because how do we produce food for very long voyage? Here in space right now, the food I eat is sent by cargo spacecrafts from the Earth. And so every month and a half, we get new food, new food, new food. But we need to start producing our own food. Here we have a little farm on board the space station. It's actually in this module, and we're trying to grow some vegetables. You might have heard of people thinking of maybe one day growing plants on Mars, and I think for these long voyages. But we'll need to have protein as well, so there's some plants that give us protein. Why not animal protein? So these are all very interesting fields of investigations. And I know that in the end, it will be smart young people like you who will invent it all.
Hi, David. My name is Lucas Groupie. I attend St. Ignatius High School in Thunder Bay, Ontario. With companies like SpaceX and Blue Origin on the rise in the commercial space industry, how does the Canadian Space Agency plan to inspire the next generation of Canadian thinkers so that we as a country won't be left behind?
So yeah, the world of space is changing, and it's changing, is evolving. It's getting broader appeal with commercial companies getting involved. I think that's a good sign of health. It means that this sector is, is viable long term. And so what's important for young Canadians is that they're well prepared, that their education matches the needs of the work market, and that they're allowed to pursue their dreams and to have a fun career contributing to these amazing projects that are going to help us propel forward into the future. So I'm really welcoming, we're all very welcoming of these this new evolution in the world of space, and ultimately it's going to benefit everybody.
Hi, my name is Erin Eastwood. My question is, how did you feel the first time you saw the Earth from space? And what message could you give young people to help us remain optimistic about our future when the people who are making decisions about our planet's health don't seem to care?
So the thing about human beings is that there's new generations, every time a new generation comes, it's a new era and a new way to think. And when I see the Earth from here, I'm just touched how beautiful she is, how strong she looks and resilient, but at the same time clearly fragile. And it convinces me that we have to be good shepherds and take good care of our spacecraft, the spacecraft Earth, where billions of people live. And she has been protecting us, recycling our air, recycling our water from the beginning of time. And I think as your generation are well aware of this, and you will make the decisions that will make sure that we have a viable future ahead of us.
Hi, I'm Reed Pitstowski from St. Alberta, Alberta. I know Canada has contributed the Canadarm1 and 2 as well as leadership in space missions, but what do you think Canada could contribute to an international Mars mission?
What an amazing dream, eh? Going to Mars. I do think that's the next step for humanity. It's the next big driver for us. And it will take a lot of smart people. The astronauts who will go to Mars, they're born yet, but they're young people. Maybe it's you, maybe people your age. And I think Canada needs to be part of this big dream because it is a kind of a good reason to sparkle imagination and keep the smartest of us involved and scratching their heads, finding solutions for everyday problems. Going to Mars, Canada, well, we could certainly contribute robotics, of course, because we are the champions in space robotics. Maybe in the medical field, maybe there's so many things we could do because our country is full of talented people and we value education. And I think really this is the raw materials for space exploration is innovation and, just a bunch of people keen to invent.
Alors, David, c'est tout le temps que nous avons avec toi aujourd'hui.
David, that's all the time we have with you today.
This was an awesome moment for all of us.
Merci.
Thank
you, everybody.
Thank you.
Congratulations again to Connor and Amy for your cool inventions. And remember, our future is in the heads of young people like you, everybody in the audience, people who want to make a difference. You can make a difference. You are the future. Keep it up.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you, Canadian Space Agency and participants. station. We are now resuming operational audio communications.